grab subject number 41 just to show you again. Okay, so what we're doing here is coming to File, Import, use EEG functions, and I'm going to come down to PDF file. File send. Done that. Okay, now because I just downloaded that subject 41, I'm going to go to my downloads folder. So see how I grab downloads here. Then you just select number 41. Okay, pretty simple. Okay, and then we want to re-reference our data to the average of the mastoids. Our mastoids are number 33 and 34. Yes, so.
We got wait.
You got what?
Did you download it before you were
Okay, then while it downloads, pay attention and take notes. Okay, so I got 33, 34. And once this is done, it's going to ask me to name it. So I'm going to name it. I'm going to name it number 41. Hit OK. Oh, that didn't work out so good. I'm going to attempt to continue. Do this over again. Goodness gracious.
When that happens, do we also want to send a report?
Yeah, sure. Why not? Set path.
Either one.
Okay, and 41. Okay, so that worked. So for whatever reason it might crash once, but then just reboot it. It seems to work. Let's say our first data set is named number 41. Now it gives us a bunch of information here. Okay, our sampling rate was at 1024 hertz. Okay, our reference is the left mastoid and the right mastoid. It's abbreviated LM and RM. Okay, and it's a good place to start. Now we have there's 900 events in the data, and we're going to see how some of those parameters change as we start to work with the data. Okay. So let's say the first thing we want to do is do that filter that we talked about that crashed our system last time, because we're sort of testing to see if this is going to work, right? So when we did that, just as a reminder, our first thing so first we loaded the data, we re-referenced to the left mastoid and the right mastoid, right? 33 and 34. So the next thing that we want to do is we want to basically do that linear detrend, right? Because we basically have that long pattern in the data that we want to bring down to read kind of normally, right? And we're going to do that by virtue of what kind of a filter that we talked about in class. You guys remember? Yeah.
High pass filter?
It is a high pass filter, exactly. Right? So we're going to do a high pass filter. And we're going to do it at a value of 0.1 hertz. Okay? So that's going to basically do the function of a linear detrend of the data. Okay? So this is we're going to trend here and we're going to detrend it so that it's kind of flat. Do you guys remember the logic behind that? No?
Regression.
Huh?
It's like a threshold and cutoff point.
It is a threshold and a cutoff point. We're going to say everything higher than 0.1 hertz is allowed to pass through. And everything lower than 0.1 hertz, in terms of an oscillation, we're going to filter out. Okay? And the low oscillations are really low because they're so long, they take a long time to do one cycle. Just like this, right? So this is modeled by coming out. Big, long oscillation. And so if we can model that mathematically as an oscillation, then we can filter that part out and just have a straight line of data. You guys remember we talked about that? Okay. So that's what we're doing here. We're coming to ERP lab. We're going to filter and frequency tools. And because we're not yet working with ERPs, but we're working with EEG data, that's going to be the option that we pick in our GUI. Okay? So, our step, alright, so 1, 2, 3, we're going to do a high pass filter at 0.1 hertz. Okay, so it's good to keep in mind our steps in the list because you're going to be responsible for doing this on your own as we move forward. Okay? So when I click that, it brings up this other GUI. And it's basically already done for you. There's really nothing that you have to do. It's really simple. Okay? Our high pass setting is already checked. That's why it's yellow. That's already set at 0.1 hertz. So all you have to do with your pretty little hand is click this pretty little button. Nice and easy, right? Now this is where it totally crapped out on us last time. You guys remember? Let's try it on a wing and a prayer and see if it works. Oh, no errors yet. You can see that it's thinking. It says high pass filtering the input. Okay, it's working. And not only did it work, but notice what happens. Okay, it did work, at least for me. Let's see if it worked for you guys. Okay, and now it's going to ask us, okay, we did what you wanted to. What do you want us to do with it? Now we want to name it or save it. So we're going to do a little bit of both. And the reason we're going to both name it and save it is because if we save it, then we don't have to go through this process again if it crashes. We can just load it in and start from where we left off, which, as you guys can understand now very well, is a nice perk, right? Okay, so it automatically appends the name as 41_filt, as in for filter. Now I find that kind of clunky because I sometimes forget what I did to data when I saved it, and I have to come back to it next week and figure out what did I do to this data. So I like to name it a little bit differently. I like to just keep it simple and just get rid of fill. Oh. I have to edit that out.
Oh, that's the wall.
Oh, it is? Oh.
That's all right. Okay. We're going to name it basically 41_. And we're going to do, you might even write out, so if you put the dot for 0.1, then it's going to assume that it's going to goof up the file name because it doesn't like dots in file names. I'm just saying 0.1 hertz. Okay? Sound good? So let's just do that. Put that right about there. Now I copy this. Notice what I do here next. Okay? Copy this, and I'm just going to paste it here too, because it's not going to automatically save it. Now the reason MATLAB won't, or the reason lab won't save it is because they don't know if you're just screwing around and just want to look at the data, but don't want to save the memory space. Okay? So what you have to do is check this box to save it. Okay? And then just copy and paste the exact same thing here. 41.1 person. And then when you're done, you just hit OK. And all that does is create that new file. Okay. So even if it crashes, we can always come back and grab that file now as it's done. So we got to do another step now. Yeah, and we did this last class too, if you remember. Actually, we did it earlier than filtering, but let's do this next. Next, we downsampled, didn't we? And what do we downsample it to? Remember here it says our sampling rate is 1,024? You guys remember what we downsampled it to? We had 256. Yeah. Okay, now let's see here. I might have a picture. Let me see if I can bring up a slide real quick. Okay, so this is kind of an example of sampling, right? So we're recording EEG, okay? We've got our event codes, we've got everything coming into our EEG. You grab a little snapshot of data here. And here, you can sample different points. In this case, these little white dots. That's a certain, right? So if you grab these dots, and then you connect them, it'll generally make that pattern, right? Because there's a lot of samples there. But what if you only sampled at half of those many locations? Right? Then maybe you wouldn't see this point up here. Maybe it would just come like this and do that. And then maybe it wouldn't come down here, but it would do that. You see how that changes? So we're going to be changing our sampling rate. 256 is still a really good sampling rate. It's perfectly fine. It's just going to make it a smaller file to work with. Makes it a lot more efficient. So that's the ideal for sample. All right, now, when we're talking a lot about filtering and sampling today, aren't we? Yes?
So does downsampling mean that you're looking at less of the dots?
Yes,
Oh.
actually. It's just that it was recorded at such a crazy level of dots that we don't actually need all that many. So we're basically, it's a good, healthy balance, essentially. Because you don't want too many where it's way too heavy to lift. And you don't want not enough where it's super easy to lift, but there's nothing in there. So the 256 is a really good, healthy balance. And so we've talked about filtering a little bit. Now some words of caution on this stuff, right? Is one, you know that we're trying to get clean data. That's one reason why we're filtering the data, right? We're filtering out that long drift. We're averaging across lots of trials to get rid of noise. Because our ERPs are tiny, right? And our effects are tiny than a little volt, a millionth of a volt. Little bitty baby effects of the unconscious mind, okay? And some of the noise that is happening, our muscle activity, goes up to almost 100 μV. So we've got to get that noise out. So we're going to be doing some of these filtering, okay? Now you notice we talked about the number of trials, right? So our signal to noise ratio is definitely going to increase if we double our trials, which is kind of what we talked about. And so, let's take a little look at that somewhere. Okay? So here, we can look at some comparisons. Okay? So these are a bunch of individual trials, and we can see some averages of them. Okay? So this is kind of, as we do this one, this is the average of this trial, isn't it? But now you average this together with this, and you get this. You guys okay in the back? So you guys good? Okay. So now, if you average this, and this, and this, you get this. And you keep averaging more and more and more, you see how these shapes change. Right? And we talked a little bit about this last time too. Right? So this is really noisy. But look how it gets nice and smooth down here. Right? See how it smooths out a little bit because you're average? It's kind of an illustration of this effect. Now, let's see here. Okay, so one thing to keep in mind as we're going through this process is that I want to emphasize one part of this slide, which is that there is no substitute for clean data. Okay? If we were at a workshop, or if I was doing a version of our own ERP boot camp down here, I'd have everyone chant it together and say, there's no substitute for clean data. Right? Garbage in, garbage out. Right? If I give you a piece of crap, all you can do is dress it up and try to clean it up, but it's still a piece of crap. Okay? So, we have a lot of really good tools to clean up messy data, but it's not a substitute for messy data. It's kind of the thing, right? Because here are some drawbacks, right? Averaging out that noise, that takes a lot of trials, and that also takes a lot of time then for people to complete those tasks. Now, if we're going to filter, right, like we did here, we did a high-pass filter. Here's the deal with filters. Every time you do something to change the data, do you know what you do? You change the data. Right? Like, you don't really want to adulterate the data any more than you have to. So every change is a change. Sometimes those changes are for good, sometimes they can be for bad, if you're not conscientious enough to keep an eye on that relative balance. Okay? So filters very often distort the time course of our ERPs. Alright? Because they're smushing things, they're filtering, they're smoothing things. They're smoothing our lines. And if they're smooth, they might be pushed earlier or pushed later. You guys follow the logic on that? Yeah? Okay. So, let's see here. All right, pop quiz. Is there a substitute for clean data?
No.
Yeah.
2 points.
Yeah, 2 points. All right. So this is actually from Dr. Luck. Okay, so we talk about signal processing, right? That's what we're doing. We're processing our brain signals. And when we're talking about signal processing, we're talking about filtering those signals. Right? Okay, so filtering, he says, is a lot like our medications. They all have side effects. So if you go to Wikipedia for Advil, right? What are some of the side effects? Just for something as simple as that. Has anybody here ever taken Advil? Most of us have, right? It's pretty simple, right? But common adverse effects include nausea, dyspepsia, gastrointestinal bleeding, raised liver enzymes, diarrhea, epistaxis, headache, dizziness, unexplained rash, yikes, salt and fluid retention, and hypertension. And sometimes those are common, by the way. The uncommon ones include esophageal ulceration, hyperkalemia, renal impairment, confusion, bronchospasms, and heart failure. You know, just uncommonly. Just sometimes the heart will fail when you take this sucker. Okay? Sorry, you can tell I'm not funded by the Advil people. Okay, so this is Dr. Luck's slide, because here's Dr. Luck's view on filtering. Okay, so according to Luckipedia, okay, filters have some side effects too. So some of the common adverse side effects of filtering equal distortion of your onset times, distortion of your offset times. That is when events happen in our experiment. Unexplained peaks in the data. Slight dumbness of conclusions can occur as a common side effect of filtering. So what he's saying is sometimes when we filter, we can change the data, and it can give us some dumb conclusions that we make about the data on accident. Now, those are the common ones. What are some of the uncommon, infrequent adverse effects of filtering? They include artificial oscillations, so creating fake patterns in the data. Also, they include wildly incorrect conclusions, right? Which is different than just a slight dumbness of your conclusion. Now it's a wildly incorrect conclusion. Also, infrequently adverse effects include public humiliation by reviewers of your papers, as well as failure of your grants and scholarship applications. Okay? So you guys kind of see the jokes and fun he's having here, but they're not wrong. The point is that just like Advil, right, or any medication, you want to take just what you need for what you need and don't do anything else beyond that. So we filter at a minimum and we change the data at the minimum level and we keep those side effects to a minimum. Now let's come back to where we were. We're going to downsample by going to Tools, and change sampling time. Okay, so should I slow down here for a second? Yeah? Okay. We'll take a breather. Actually, it's a good time. It's about 1:25 right now. You guys want to come back in about 10 minutes? We've been going for a little while. Does that sound good? Give you guys time to catch up? Okay, we're going to start in 10 minutes from now, which will be 1:35. And when we do that, please have all the files that we talked about downloaded. Please have Matlab loaded, EEG loaded, your path set, and hopefully import that BDF, number 41. Do exactly what we did, average to the 33 and 34. Do the high pass filter at 0.1 hertz. If it crashes, reboot it. It looks like it will work then. And in 10 minutes, have it ready to go at this point for our change sampling rate. And I'll come around, we'll help you guys get on track. Does that sound good? Okay, cool. Oh, that's a good question. Not at this precise moment. Those are the big ones. If we have to download the other ones, I mean, you might as well just download everything from the Blackboard site because the other ones are really small and they'll go really quick.